This is TWIS, This Week in Science, episode number 855, recorded on Wednesday, December 15th, 2021. Bringing TWISmas cheer with science. It's what we like to do. Hi, everyone, I'm Dr. Kiki, and tonight we will fill your head with organs and mammals and TWISmasy stuff. But first, thanks to our amazing Patreon sponsors for their generous support of TWIS. You can become a part of the Patreon community at patreon.com/thisweekinscience.
Disclaimer, disclaimer, disclaimer. Well, maybe you've been to school for a year or two and think you've seen it all. What you really need is a holiday in science. Yes, it's beginning to sound a lot like TWISmas. Intro to the show. A pair of NASA probes and a rover that robes is the wish of Barney and Jen. A robot that walks and goes for a talk is the hope of Janice and Ben. Beautiful sight, habit at night, talking in a science wonderland. As we hoop-dee-doo and decorate dark into the holiday season with science stories coming around. We want to wish you a Merry TWISmas. We wish you a Merry TWISmas.
And a
Happy New Year. Before we are off, dashing through the snow and a science podcast sleigh. On the air we go with This Week in Science all the way. Coming up next, not everything you've planned for Christmas is going to go exactly the way you expected it to. And it's okay. It's fine. It's all part of the holiday story.
But what you do expect is This Week in Science.
Coming up next.
I've got the kind of mind that can't get enough. I want to learn everything. I want to fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I want to know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kiki, and just Kiki, no Blair.
No Blair. It's just the two of us this TWISmas. Yes. Yeah.
I like
Just
all
like
the
the good old
decorations
days.
you put up. These are nice.
In the last week, there have been a couple of birthdays. Happy birthday to you, Justin. And
yeah, thank you.
you're welcome. And happy birthday to Blair out there
Yeah.
enjoying her holiday. Oh, we're all about to have a lot of fun, though, because you know what? TWISmas is a time to celebrate science. And we have a whole bunch of science on the show tonight.
Oh my goodness, yes we do.
Just because Blair is not here doesn't mean that we're missing the science. I mean, we're going to miss Blair, but we have a ton of science to go through. So I have stories about bomb diffusion.
Ooh.
Yikes. Some new organs. Well, how do we get organs anyway? Where did they come from? Krypton. Yes.
Oh.
And it could be a Superman reference, but it's not. Details coming up soon. I also have a bit of a positive, well, not positive, a COVID update and some plastic brains. What did you bring, Justin?
I've got NASA gets corona, dragon worm dogs, raining shrews, bogarting birthdays, 10,000, 2,000-year-old monoliths, and Neanderthal pyromaniacs.
That sounds like a party, if I ever did hear it. And I think, you know, you're bringing a bunch of animal news, so I think we've got animal corner-ish topics covered as well. As we jump into the show, I do want to remind all of you that if you're not subscribed to us in all the different places, we are in all the different places. We are on the podcast platforms. Look for This Week in Science or TWIS. We are also on YouTube, Facebook, and Twitch, live streaming every Wednesday at 8 p.m. Pacific time. We are TWIS Science on Twitch, on Instagram, on Twitter, and our website is twis.org. But now it's time for the TWISmas Science Merriness. Okay, let's go with the Superman first. Want to dig into Krypton?
All right.
All right. So, a planet called Krypton, where the people that spawned a superhero called Superman. He came to Earth, there was tragedy and all that kind of stuff. But anyway, his kryptonite was kryptonite, and well,
It's like
kryptonite,
allergic to it or something.
yeah, pretty badly.
Really
But there is Krypton here on Earth. It is an element, but it really is not in the element Krypton, the mineral Krypton, the kryptonite that causes Superman all sorts of problems. So really, this isn't a story about a far-off planet. This is a story about our very Earth and its ancestry. How it came to be not populated, but seeded with elements like carbon and nitrogen that are in our atmosphere, water. Where did all this stuff come from? In order to discover this, researchers at UC Davis looked at volcanoes. They studied magma that was being shoved up from the mantle of the Earth in places like Greenland and Iceland and the Galapagos Islands. This research looking at the magma that's welling up, being pushed up from the mantle through the pressures that are there. This is old material from deep in the earth. And so it is indicative of earlier phases of the Earth's formation. And so looking at these volatile elements, water, carbon, nitrogen, these researchers have determined that a lot of these volatile elements actually came to be part of Earth before the big giant moon forming impact that created the moon and created the Earth that we now know. There was an early young Earth in which, where did this stuff come from? And we've had ideas of comets and asteroids and all sorts of things. Last week, I talked a bit about the solar winds, or maybe it was 2 weeks ago. I talked about solar winds causing oxidation reduction reactions and leading to hydrogen and water on grains of dust in the solar system. And so this evidence that's coming out of UC Davis and also with researchers from ETH Zurich in Switzerland, it really, really adds to the evidence that there are multiple sources for all of these elements within our Earth. And that, yes, some of it did come billions of years ago in the form of, during the volatile period of our solar system's formation, in the form of meteorites, chunks of space rocks landing on the Earth. But it also came from dust raining down onto the Earth. And that a lot of what we know to be in the Earth now it came from these early processes. And the strange thing is, okay, the volatile elements that you think would have disappeared, that they clung to the rocks of the Earth, even during that massive impact that made the moon. Yeah,
So the stuff that's in the Earth is older than the moon?
Yeah, or that the stuff that's in the moon partially is part of, yes, because the moon is made partially of the Earth.
Yeah.
And the merging of the big planetesimal that ran into the Earth and caused the moon to be formed. Yeah, but what they say is the study provides clues for the sources and timing of volatile accretion on Earth and is going to help researchers understand how not only the Earth formed, but other planets in our solar system and planets around other stars as well. So this whole process of a Earth creation, rocky planet creation. Yeah. So anyway, they got these gas bubbles from lava to sample this old noble gas, Krypton, and they were able to determine the Krypton isotopes and the signatures of the different isotopes. In the mantle Krypton, it differs in its isotope ratio from the atmospheric Krypton ratio. And also the atmospheric ratio of carbon and oxygen and water is different than what is in the planet itself. So they've determined that not our atmosphere didn't necessarily come from the same source as the rocks of the earth.
Ooh. Okay.
Yeah.
Multiple origin story.
Yes, multiple origin story. Exactly. That there are multiple different ways that these volatile elements have come to be a part of everything.
Very
Basically, it's a
cool.
lot of stuff falling on the earth over a long time at different times. Before the moon and after the moon. We should have like pre-moon and post-moon periods. Do you want to
Do a
tell
wardrobe
us?
change here.
Oh, you're doing a wardrobe. He's putting on a hat. The TWISmas capping is begun.
There we
The
go.
TWISmas cap.
Now I'm a little bit more in the season.
I don't have a kerchief, but Justin is in his cap. Ah, yes. Anyway, interesting work out of UC Davis on the origins of really interesting compounds that make life possible here on our planet.
Yeah.
The thing that also makes life possible on our planet is the sun, which we reached out and touched it almost. What did we do, Justin?
Set the controls for the heart of the sun. Some out of the world corona news. NASA's Parker Solar Probe is partying on the sun. Back in April, the Parker probe reached the sun's extended solar atmosphere, aka the corona, and spent 5 hours there, entering and exiting the boundary about 3 times. The data of that interaction is just now being analyzed, confirming that the spacecraft is the first ever to enter the outer boundaries of our sun and is the fastest object ever created by humans. Current speed of between 370,000 miles and 600,000 kilometers per hour. The fastest man-made object ever. Probe made its first direct observations of what lies within the sun's atmosphere, measuring the phenomena previously only estimated from the Earth. Ooh, wow, got bright. And so far, things have actually been pretty strange. It's not exactly what was expected. Sun's outer edge begins at something called an Alphean critical surface, point below which the sun and its gravitational magnetic forces control the solar wind. Beyond it, the solar wind goes accelerating away from the sun super fast. The sun's outer edge then was penetrated by this probe. Surprisingly, they found that the critical surface, that Alphean surface, is wrinkled. So as the probe went through, it sort of entered and re-entered the boundary of the sun's interior without just going directly in. So they got to figure out why that is, why it's not just uniform. Their data so far suggests that the largest and most distant wrinkle on the surface was produced by something they're calling a pseudo-streamer, a large magnetic structure that is found back in the innermost visible face of the sun. And they don't currently know why that pseudo-streamer on the surface of the sun is pushing this critical surface, which is far away from it, away from the sun, but it seems to be having that effect. Researchers also noticed far fewer switchbacks below the Alphean critical surface than above it. Finding could mean that switchbacks do not form in the corona. Probe also recorded some evidence of a potential power boost just inside the corona, which might point to some unknown physics affecting heating and dissipation that they hadn't anticipated taking place. So having achieved its goal of touching a star, Parker Solar Probe will now descend even deeper into the sun's atmosphere and linger for longer periods of time, which should be just fine because the temperature further in to the sun
It's cooler.
It's cooler than the outer. Yeah.
It's still very hot, but the technology behind the shields on this solar probe is amazing. It's the ability of the shield to block, to dissipate that solar heat is incredible. You can put a blowtorch on one side of the heat shield. It's several inches thick. You can blowtorch one side of it, and the other side stays cold. The heat doesn't really transfer through. I don't know, but this is a probe with a death wish. We're going to be getting a whole bunch of. This is like the TWISmas science version of Die Hard.
Oh gosh. Is there a suicide in Die Hard? I didn't think there was.
No.
Look, yeah, it does remind me of the Pink Floyd song, "Heart of the Sun." Set the controls for the Heart of the Sun. That's what this probe has actually done. I'm actually was surprised to know that this is the first time we've sent anything into the sun. I would have expected we would have been sending things into the sun long time. Like that's one-way trip, get as much data as you can before the thing melts. But they waited till they got something that wouldn't melt before sending it to the sun, which I guess is smart. I guess that's wise.
Well, if you're conserving resources, you know that it is going to be a one-way trip, not coming back. How can you create something that will last long enough to be able to send sufficient data back that won't be compromised by the magnetic fields, by the cosmic rays, by everything that comes from our sun?
Fastest craft ever made by man. Pretty good speed there that thing's built up. And it's not like, if you look at it, it doesn't look like a fancy fast flying spaceship that you would expect. The fastest ship ever to be. It looks like a little satellite probe looking thing. But it's...
Yeah. I can't wait to see like
gravity that's pulled into is making.
Yeah, I mean they've done a pre-analysis now of all this data, so I guess it's going to be like what else is going to come from the data as they analyze it further. What more as they go deeper into the corona?
Yeah.
It's so exciting.
More and more.
We're not just.
Yeah.
We're touching the sun.
It should be safe because it's in the millions of degrees, and that's millions of degrees Fahrenheit. If you switch it over to Celsius, it's millions of degrees. It's still that hot. It's the
really
same,
hot.
Pretty much, really just super hot at that point.
You would not survive. I would not survive. But
no, but it's going to get cooler. Still not human survivable cooler, but it's going to get much. I think it's like a magnitude or more cooler as it heads into the interior. So it's gonna should be fine. Should be able to report back, no problem.
Should be no problem. You know what else is cooling down? India's population growth.
Oh gosh. I hope this is not a corona story.
This is not a corona story. Okay. This is a story of some questions about methodology in which this target was reached. But it's a success story in a country that seemed to have an explosive population growth rate, massively contributing to the human population here on Earth, with a replacement level of more than 2.1 children per couple, per woman. The replacement rate is basically 2.1 is replacing the partners in the relationship. 2 children for 2 parents. But in this announcement, the National Family Health Survey in India has announced that the fertility rate has for the first time fallen below this replacement level, and that it is on a track to continue decreasing a bit, and that even though there is a population boom that they're still dealing with, and so they will experience growth in the population until about 2050, probably to about 1.8 billion people in the country. With the decrease by the end of the century, they will potentially be in negative population growth, which is good news for the Earth as a whole. This was achieved through planned family planning, through sterilization, through contraception, and through education of women. And it was an effort that the government has been working on for years. However, in the 1970s, this is not the best story in the long run. A lot of countries have made big mistakes when it comes to sterilization. And in the 1970s, Gandhi allowed the operation of compulsory sterilization camps in which about 19 million people, 3/4 of them being men, were sterilized, were ordered to be sterilized, not consensually necessarily. Sterilization was only compulsory for 2 years, according to an article from Science magazine. And after that point, they offered about $15, up to $15 for women to be sterilized. So there are still debates as to whether that or not the monetary incentive is related to coercion or whether it's just, hey, we're helping you out.
So that $15, are we talking 15 US?
Yes, $15 not what.
Then what does that translate into weekly, monthly, yearly?
And it depends in the more rural,
region.
the more impoverished rural areas. That's going to be a significant sum of money, especially going back into the 1980s.
Yeah. And then is it then you're talking also, it's like, hey, yeah, there's not enough food to go around here these days, as can happen in India. And is that $15 something somebody will take up in an emergency to feed existing children or themselves? And then, it's just, that's just not I completely see the point of needing population control, and it seems to go just fine if you just give women the rights to their reproductive system.
The right to choose. Yeah. And education. Education.
Correct.
Yes, education, and that's something that I want to stress here, that the availability of family planning services, the availability of contraception, the availability of female education, for everybody to be educated, really, that when people who can bear children are educated about the responsibilities of bearing children, about the options that are available to them, it is better for everyone. And when women are educated, as in educated beyond just, this is what you can do for contraception and families, but actually educated, going to high school, going to college, learning about the world so that they can get a job and afford to have a family if they want it. That becomes a big incentive. And actually, it's one of these things. It's a big question for a lot of governments. As more women are educated and choose not to have children, what does that mean for future population growth? Many countries, now they're looking at India as being one of them. The United States is another. Many Northern European, Scandinavian countries are in this group. Negative population growth is going to impact the economy because you do not have as many young people able to work. And then additionally, you don't have as many young people within the public health system to take care of your big aging population that occurred before. So there are downsides that have to be managed, but they are not unmanageable. Just with educating women, availability of contraception, and family planning services, that's pretty much all you need to create a recipe for, not necessarily having a growing population. Let's talk about we were talking about humanity on Earth. Let's talk about parasites.
Yeah, this is oh gosh, we got so close. So efforts to eradicate a human parasitic disease are being hampered by dogs.
Oh no.
So we were so close. But
dogs are our best friends. Why would they do this to us?
Because they're evil. Like deep down, they're not evil. They're just gullible.
No, they're
just gullible. They're just dumb dogs. Parasite Dracunculus meridensis, or dragon worm, is a roundworm nematode that causes a disease called guinea worm disease. The disease is basically a result of a parasite's reproductive cycle taking place in an animal host. When it takes place in humans, those humans find it to be most unpleasant. So the initial sort of target of the worm in this cycle here is a freshwater crustacean known as a water flea, where the worm's larvae seems to accumulate. I don't know if they're just getting stuck to it or if the water fleas are gobbling them up, but somehow these water fleas accumulate a bunch of the worm's larvae. Then they get caught up in some drinking water. So guinea worm disease is usually caught by drinking water containing these water fleas that are then themselves carrying the larvae. If you happen to drink a bunch of worm larvae, nothing noticeable happens at first. Though going unnoticed are the hatched larva worms mating and growing inside of your body.
No!
Yeah,
Merry TWISmas!
But things are still fine until about a year later. Year of growing, mating, and reproducing and producing new larvae inside of you. Long after you've forgotten about that, having sipped that water unfiltered from a stagnant pond in Central Africa, thinking you are well clear of any ill that could have come from that carelessness, painful blisters begin to form, typically on the arms and legs. They create a burning sensation. And
that's where the worms are. It's not blisters, is it?
No, it's blisters. It's just blisters. And they have like this burning sensation to them that you feel immediately compelled to say, oh, put those burning sores in some cool, cold water. And then as soon as you're touching that water, adult worms begin to emerge from the blisters. Because they're wanting to then shed larvae back into the water,
right,
to continue their life cycle.
That makes sense.
And these adult worms, when they emerge, they're very small, teeny tiny little things. They're around. They're small around, but they can be anywhere from 3 feet to a meter long in length.
3 feet to a meter.
Yeah, somewhere in there.
Right in there. You
can pull them out, but only just a few centimeters each day. So removing them can take weeks. And you have to be careful not to kill them, because if you kill them, if you break them off, if they die in you. And they decompose, and the remaining worm beneath the skin can cause all sorts of problems as it decays away within your flesh. Now,
I think
terrifyingly,
it's almost as hard. It's probably as painful to have it as it is listening to you describe it right now.
This is not a. Hey, this is only on the Christmassy show because it happened to be published. Yeah,
I grew up with that "Where There Is No Doctor" book, and I'm still having a hard time with this. Okay, keep going. I can do this.
Okay, so bad news is around in the 1980s, there were millions of cases of guinea worm a year. Millions of cases of this. 2020, there were just 27. Largely through education and the introduction to personal water filtration systems, even to the point where you can get a straw. If you're in Central Africa, it's pretty accessible to get a straw with a filter that's sufficient to drink from one of these stagnant ponds if you need to. That prevents water fleas from being uptaken, so the larva stays out, so this guinea worm disease almost completely eradicated from humans. It would be only the second disease since smallpox that's been completely eliminated.
But the dogs. Now you have to tell us where the dogs come in.
So yeah, just now, it seems like it was going away. Turns out it is thriving in dog populations. In 2020, they did a bunch of testing. They even had satellite tracking on these dogs to try to figure out where they were going, because 93% of guinea worms detected worldwide now are in dogs, and specifically dogs in Chad, Africa. So this is This is very now specifically in dogs, and they after some research they figured out. This is research by the University of Exeter. They found that dogs are eating fish that were caught by fishermen and discarded. So these are small fish that maybe didn't make it to the meal. This is cut up guts from the fish that they're being fed to the dogs that are containing these parasites. So uncooked fish being fed to dogs is maintaining this population.
So cook the fish
Before you feed it to the dog?
before you cook the food before you eat it, or maybe freeze it to the point where the parasite dies. Yeah, there are
or
methods.
stop having dogs. I don't know what the right.
I don't know about that solution.
Well, if you're gonna keep having dogs, maybe don't feed them the raw fish if you're in Central Africa.
Yeah.
But it's a good story because we almost got rid of it, and it's got a little reservoir, but we've identified it.
So that's the good news.
Yeah.
Just good news.
Just good news.
We identified the reservoir for a parasite, so now we can deal with it.
Yeah.
However, that the public health
and more just good news. You may never have to hear a description of that worm again. Guinea worm disease. You may never have to endure that again.
I would like to never have to go through that again. That would be great. I would really appreciate that. Please. So let's talk about let's move on to some other interesting topics. Like, I don't know, worms have organs, dogs have organs, all animals have organs. Organs are composed of multiple different cell types, all working together for some overarching function. So, like your stomach digests your food, your kidneys filter your blood, your spleen. Does anyone really know what the spleen does? No, I'm kidding. The spleen is very important. But organs, where do they come from? Where do they come from? Researchers publishing in Cell this last week have been looking at a little beetle, a rove beetle, and its defense gland to answer this question. And in looking at this defense gland, they have determined that there have been, through the evolution of the beetle, it modified cuticle cells in its exoskeleton and other cells within a different pathway, and kind of put them together, merged them, and adapted the cells so that they all started working together and created a gland that the beetle could then use for defense. And so this is an unexpected cellular, what they're saying, coevolution, and that it is this coevolution of purpose between multiple different cell types coming together that allows for organ level properties to be selected. They say that in their abstract, we show that evolution of each cell type was shaped by coevolution between the two cell types, yielding a potent secretion that confers adaptive value. Our findings illustrate how cooperation between cell types arises, generating new organ-level behaviors. So your organs, they didn't just come out of nowhere and it's just like, you have a spleen. No, that's not how it works. There were step-by-step processes that different cells began to work together for a common purpose. It's pretty, I find it very interesting. The evolution.
Yeah. The
evolution of these organs, these cell types, and interesting that just studying a beetle can lead researchers to these larger realizations.
Yeah, human body itself is just an incredible thing. But to know that, like, we could have had a couple different organs. We could have had like a venom sac. We could have had We could have worked on some other tissue as well, apparently. Like, it was all out there available.
We could have had a venom sac if we, decided to take cuticle cells from our skin and, our things that became fingernails. Maybe they could have been venomous fingernails.
And the thing is, now thanks to the wondrous breakthroughs in science, we still can have those things.
We still can.
Maybe in the future.
Yeah. So anyway, what they were able to do is figure all this out, not just by looking at the gland and going, look at that, all the types, they must have merged together. They looked specifically at the molecular architecture and were able to use single cell transcriptomics to determine the pathways for these defensive compounds in what they call the Turgel cell. It's the Turgel gland cell types. And they were able to infer transcriptomic and pathway relationships to be able to, between the cell types, to be able to trace how it was assembled over time. So the transcriptome being the transcripts, the messenger RNA, the mRNA, the pieces, little bits and pieces that are copied from the DNA to go on to make proteins and create the rest of the organs.
So if you have well, I mean, I'm sort of thinking for like if you wanted to actually do like create the humans with venom sacs, that's not a thing anybody really, I don't think, wants to have. But when you're sort of doing artificial engineering of evolution, you're trying to push things in a direction. You might want a tissue that does a function in a small microorganism in a biotech setting, for instance. One of those Chinese hamster ovaries, one of those things, or yeast or bacillus, some kind of a thing like this that you're trying to add just a function to. Knowing how cell tissues on a larger scale get directed into becoming a thing might be useful. I don't know.
Yeah.
Maybe we're beyond.
Evolution in a dish. We'll see how that goes. Hello, sci-fi. All right. You want to tell me another story? Do you have one more here?
Yeah, there was a major mammal discovery manifesting in the description of 14 new species of shrews. Largest number of new mammals described
Shrews
in the scientific paper since 1931. So it's been a while since one paper held as many as 14 new species of mammal. Kind of a long record. It's a long time since this has happened. This is a decade-long journey of taking inventory of Indonesian shrews living in the island of Sulawesi. Group of scientists led by LSU mammologist Jake Esselstyn has identified the 14 new species. They detailed this in a recently published paper in the Bulletin of the American Museum of Natural History. The quote from Esselstyn is, I really like this. "It's an exciting discovery, but it was frustrating at times. Usually we discover one species at a time, and there is a big thrill that comes with that. But in this case, it was overwhelming because for the first several years, we couldn't figure out how many species there were. So a clearer picture began to emerge once the research team examined not just what they could find in their searches, but also the extensive collection of genetic and morphological data from the other species that were collected back in 1916. They ended up with 1,400 specimens in all and recognized 21 species of shrew on the island of Sulawesi, including
That's a
14.
lot for one island.
It is. That's the other remarkable part of this story. So it's a lot for one big island. It's a pretty decent size for an island, big island,
but still, I mean, that indicates that there are
shrew.
all sorts of different ecosystems that would have pushed the adaptations that would have led to the eventual speciation that occurred.
Yeah.
Right? Maybe there were population bottlenecks. Maybe this is fascinating.
Yeah. So this is he's going to keep studying those shrews there, but It's also, yeah, like you were saying, it's a great way of looking at biological evolution, and it's going to be a wonderful thing to sort of study for a long time to come. Especially since you got 21 species currently there. That's fantastic.
That's a massive increase just go mammals. There's more of us now that we named them.
Yeah, that's the thing. They were already there.
Yeah.
But if all 21 species are just called the shrews of Indonesia, and it's just the shrews, But knowing that they have individual speciation, pretty.
And I think definitely understanding what are the environmental forces at play that allow them to be species, and how can we pay attention to that for conservation and maintaining ecosystems and knowing what's necessary.
Yeah, and if
to
you
keep
didn't
individuals alive. Yeah.
And if you didn't know that there was 21 individual species, as a shrew breeder, having a shrew farm might explain why it hasn't always been successful breeding shrews if they're all different species that you've been bringing in.
Exactly. Oops, I got the wrong one. I didn't know they didn't like each other because they're not recognizing each other. That's not necessarily how it works. We hope you're here recognizing This Week in Science. This is our TWISmas episode. So far on the show, it's been full of kind of disturbing presents, but I like having a whole bunch of shrews under the tree.
Oh.
Yeah. Am I shrewd for thinking that? Thank you for being a part of TWIS. We're so glad that you are enjoying science with us. All right, I'm going to come back with a COVID update. So we've got some COVID news for you. COVID news for you. Yes! Omicron continues to spread rapidly, very rapidly around the globe, spurring heightened alerts by public health agencies and local governments. At least one American university, Cornell, has shuttered in-person finals, and graduation has been canceled as a result of a dramatic increase in cases on campus of COVID-19 and evidence of Omicron in their testing. They have shut everything down in the hopes that it's going to prevent a larger outbreak in the community. And scientists are warning that although Omicron might not result in serious disease as often, especially with high rates of vaccination and previous infection in many places, the transmissibility is enough that the sheer number of cases will very likely overload hospitals if people do not play their part and take prevention seriously. So, here is a list of TWISmas safety recommendations. Get your booster if you're vaccinated. That's really going to help. You should do it this week so you're ready for it next week. That would be great. Take ventilation and masks seriously. Open those windows if you can. HEPA filtration works if you've got HEPA filters. And definitely dig out those N95s, KN95 masks. Definitely for the win. Be transparent. Talk openly with your friends and family about risk factors. Where have you been? Who have you been talking to? Where have they been? Who have they been talking to? Who needs to be protected? You need to have these conversations if you have not yet had them with your family and you're planning to spend time together over these holiday weeks. Rapid testing is your friend. Rapid tests can really help to determine infection or lack of contagiousness. So is PCR. PCR might be harder to come by, but it's there, and we should use these tools to our advantage if we can. Think about ways to reduce your potential for infection. What can you do? What can you as a person do to be good for your community? If you have concerns, talk to a doctor, check the CDC website, and do your best to keep your community protected. We are all in this together.
Yeah. So
I'm making a list and checking it twice for Christmas. Is gonna be nice if we all are doing our best.
I haven't gotten the coronavirus yet.
The Rona.
I haven't gotten the vid.
The majority, pretty much everybody will probably get it eventually. I mean, that's what's going to happen.
And I'm starting to think of it in terms of the yet, because
that's how we should all kind of get to at some point. Yeah.
And I'm like, is this a? This one is going bad. Like, this is I think the UK is saying that they're going to be. This is going to be the predominant species or variant causing infection in the UK by the end of this month.
Yeah,
it's going to take over. It's had a 40% daily increase, I think, something horrible like that. Like, it's really insanely taking off. Much more transmissible. Like you said, even if it's less deadly to an individual basis, it's going to hit more people. It's just more shots at causing human suffrage.
Yep. And it is a respiratory virus, so masks can help to slow the spread of those respiratory aerosol particles and the droplets that we've heard so much about. And additionally, what else was I? The transmissibility. Part of what makes it more infectious is, from what they have seen, is that it gets into cells and replicates inside cells much faster even than Delta. So the rate of viral proliferation within your cells is very high, but it's in the bronchioles. It doesn't do a good job of replicating in the lungs, and they don't know why that is yet, but they're hoping that maybe what this means is it's going to be more transmissible, but if it's not getting into the lungs as easily, perhaps it won't be as severe. And we also know that so far, it's been a lot of younger individuals who have been infected and who are showing up as having been exposed. So we don't necessarily know if this is like a population age group bias or if it is actually a less severe virus. Could also be vaccination and previous infection are allowing people to fight it off a little bit, even though it might be evading some of those defenses. There are so many questions still, but the best we can do is to remember that we can do our best. Our choices matter, and our choices will affect the future. And speaking of the past and the future, I have a retracted study.
Oh.
Yeah. So back in March or something like that, there was a study that came out finding no effect of lockdowns on COVID-19 deaths. And some researchers went back and looked at the data, and they found that the methods were faulty. They tried putting data into, like fake data, into the model that the original study used, and they found they could not, even with data that would show that there was an effect or was an effect. The model didn't work. The model was faulty. So really, the faulty methods were unable to actually find the effects that they reported, even if they did actually exist. So,
wow,
the authors have retracted the paper.
Yeah. Test your models, boys and girls, before publishing your science papers.
Yeah.
Make sure your model is telling you something, not just noise.
One of the good things about this also is that the researchers were very transparent. They uploaded all of their data and their model to a research database so that other researchers could model their data and do what they did. And that is what allowed the other researchers to come in and say, oh, you actually didn't do this right. We put in more data, more numbers, and it's not working the right way. The researchers were very unhappy about having to retract their paper.
Yeah.
But they did, and it's good for everyone. Although the harm has already been done, because this is the kind of thing, it's like the first headline that's out there. If you retract a news story, people remember the original. They don't remember the retraction. So this is in the public sphere. The original lockdowns don't work is the take home message. But now this retraction is we have to work very hard to let people know that this study didn't actually show that.
Here's what's really tricky about this. You do the study, it says lockdowns have no effect. If you're a rational person, which maybe none of these scientists were on this common sensey rationality thing, you go, hey, that doesn't make any sense. There's no way that having a lockdown during a pandemic has no effect versus not having a lockdown. This just can't be right. Let's go check all of our models and see what's going on here. On the other hand, if the scientist doesn't like the result of their experiment and decides to can it and try again, that's confirmation bias.
Yep.
So you kind of have to go, oh gosh, oh, we're going to have to publish this. I don't like it. I don't like it at all. But I kind of have to because this is the result that we got. And somebody knock it down or tell me I'm right or wrong. Yeah. That's fine. Here's how we did it. Ugh, not my problem now. Other people can look at this because there is when it comes to giving a health something that can be taken as a health advice, I kind of agree. Maybe they should have waited longer. Maybe this one didn't need to publish so soon. But again,
they thought they thought they had something, so they needed to publish what they had.
Yeah, so,
it was a bit of that. This is This Week in Science. We hope we are filling your day with merriment and cheer and a whole bunch of science this year. Science today, science this year. That's what we're all about. I do have a few calendars yet left, so if you are interested in getting your 2022 Blair's Animal Corner TWIS calendar, head over to twis.org, click on the frog, and order away. The order is through PayPal. I will be able to mail them out until Wednesday of next week. So if you want them before the new year, hopefully the mail will work that way to get them to you in time for 2022. This is This Week in Science. We thank you for your support. We really can't do any of this without you. Thank you for everything. All right, Justin, we're going to come back right now, and I think it's your turn because there's no animal corner. What do you have?
Oh yeah, let me see the order of the things. Oh yeah, here we go.
It started snowing here, by the way.
Oh wow.
The snow is falling in the dark. What do you have?
Researchers from Washington State University have evidence the giant stone monoliths of southern Ethiopia are 1,000 years older than previously thought.
Ooh.
The Saqqara Soto is known to have the largest number and highest concentration of these megalithic monuments in Africa, with an estimate of more than 10,000 of these things in 60 or more different clusters. And to be clear, these aren't just phallic stones raising up out of the landscape. These are 10,000 carved penises jutting up. Some 6 meters tall. Others as much as 20 feet high.
What?
Huh? These are they're penises. They're not just phallic like a tall obelisk of carved stone might generally be phallic. No, these ones have a little bit more detail to them.
And we're just figuring this out?
So no, we've so this is the thing. It's
they're 1,000 years old. We didn't figure this out before now.
They were thought to be 1,000 years old.
Okay.
It turns out they're more like 2,000 years old. So these were first studied by some French researchers back in the 90s. They said, probably year 1100 AD. And now they've gone back. They're under consideration for being a UNESCO World Heritage Site. But they still haven't. They've been there in that holding pattern for a while. Still haven't gotten approved. And I'm thinking it's because at some point, the World Heritage Site is going to be 10,000 stone penises, many of which are 3 meters high. That it's just It's a World Heritage Site. These are 2,000-year-old, and it's an amazing site. Yeah, but those are penises.
They're large stone obelisks.
No, they're not just obelisks. Those are some pictures. Go Google it up and pull up some other photos. Some of them are much more obvious about what they are than being simply.
I'm gonna refrain from Googling.
But no, this is an archaeological site.
Right, and researchers are going and looking at the old stone penises and going, those are old.
But they seem to have some significance too. It seems like generation after generation, some of these were burial sites. Some of them seem to be showing the transfer of power between generations.
Huh.
I'm assuming it's a male-dominated society. There does not seem to. Yeah, yeah. The researcher who went down there is Ethiopian of descent. Researchers out of, I think it's North Dakota, University of North Dakota. At least, I lost the story here. But we actually initially went down there was going to study some caves or something. This is Ashanafi Zena, who's the lead author of the study, doctoral researcher now at the State Historical Society of North Dakota, gone down to study caves, and came, went to go look at these things and went, "Oh my goodness, this is an incredible archaeological site," and very little study really had been done on this, even though it's been there for thousands of years. So, looking at the stones, many of which had fallen to the ground and some have broken to pieces, I decided to focus my dissertation work there instead of investigating cave sites in southern Ethiopia. One of the things they discovered, aside from some sort of the getting the carbon dating right on these stone structures, was the obsidian that had been identified at those sites was sourced some 190 miles to 300 kilometers away in northern Kenya. So that also illustrates that thousands of years ago, pretty extensive trade routes were already operating across Africa. Allowed the trade,
which is not surprising when you think about it. People have been living in Africa for since the beginning, and it's not surprising that people would be having trade routes and moving from place to place.
Yeah. So in Western Africa, it's very well known what the sort of trade routes that existed, because you had people who were living in sort of different ecological regions, some plains, some more jungle, connected by rivers. And there's some really nice record of that trade going way, 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 way back. There wasn't, you get to the western side, and that the records of trade sort of fall off. So there has been this idea that African society sort of was burgeoned in West Africa, and then as trade and connections to, I guess, from the camel. I guess once the camel could cross deserts and they could trade with the regions further and further away, there became an additional livestock available, and there's another big expansion there. But I think a lot less is known what went on during those times in sort of Eastern African trade routes. But yeah, so a lot of fun stuff. But I have a feeling, I really do, the idea that this is a World Heritage Site and it's been delayed and there hasn't been that much research done on it, even though you have 10,000
of them. That is
obelisks. I mean, look at how much Stonehenge gets looked at. I mean, there's no 10,000 stones standing up in it. The only reason I can think is that the vast majority of these obelisks are carved to look like penises, and that apparently has some effect on their ability to be researched.
Possibly, or it could be that people have had not had enough of a real academic interest in the cultural heritage of many civilizations, tribal
Bradley White
in Africa. Yeah.
Chat room is saying bone henge. No, these are not made out of bone. They're made out of stone, but you can't use henge because that's a different. Anyway.
So many. I'm fascinated with the significance of it. Like this, it's definitely power related, but like you said, generational shifting of power. There's celebratory aspects of it. It's fascinating. Fascinating. And the way that, a Beavis and Butthead trained mind initially heads is not the direction that other people will think of it. You have more stories?
What are you talking about? Yeah, I got a bunch more. As we approach,
I grew up on Beavis and Butthead. I very infantile at times. Yeah, you got it.
As we approach December 25th, they're prepared to celebrate the birthday of the beloved baby Humphrey Bogart.
Was it Copernicus or something? Galileo's birthday is coming up.
There's also like a dozen or more famous, once popular deities who are specifically born to virgin mothers who are also born on this day. Like there's like a long list. Many. It's a very popular day to be born to a virgin mother. So somebody needs to do the backtrack, right? The 9 months, the 40 weeks back.
Yeah.
From the date and figure out when is God getting randy? When are the gods? I mean, like, I need to.
In the springtime because it was spring. I mean, come on. Okay. What you got? Go. What you got for me here?
All right. So let's have a pregnant pause for a moment and think about the mothers and babies in this time. Nearly 1 in 4 pregnant women in a new study say they've been unable to afford necessary health care. 3 out of 5 have concerns about paying basic medical bills. Pregnancy and the year after delivery are a critical period for health care access for expecting mothers and babies. Yet more than half of women in a 5-year study describe general financial stress over all their expenses, including monthly bills, housing costs, minimum payments on credit cards, maintaining good standard of living, just getting through the pregnancy and the sort of post-pregnancy period. This is quoting Michelle Moniz, who's an MD and obstetrician gynecologist, University of Health Voigtlander Women's Hospital, senior author of the study. Our study suggests that financial hardship is exceedingly common among the birthing population in the United States, with many parents experiencing unmet healthcare need due to cost, healthcare unaffordability, and general financial stress. These findings appear in JAMA Network Open, include a national sample of 3,500 peripartum women between 2013 and 2015. Prenatal and postpartum visits provide essential preventative services for both women and infants, including vaccinations, screening for gestational diabetes and anemia, an opportunity to do early diagnosis and management of pregnancy complications, Moniz says. But for some, the cost of healthcare is a barrier to actually utilizing these services that are recommended. Women with private insurance and those living on lower incomes were more likely to experience unaffordable health care than women with public insurance and those with higher incomes, the study found. 24% of women with unmet health care need reported during being unable to afford the medical care. Prescription medications, eyeglasses, mental health care, or said that they or a family member had delayed or deferred needed care due to costs. People who delay or forego medical care due to financial barriers are more likely to report worse health outcomes, says Moniz. Financial hardship has also been shown to be associated with poor mental health. Household income often fails dramatically around the time of childbirth. This is something that there was a study, I don't know if we talked about it, that Germany had done that showed like that having a baby also had an 18% decline in income for mothers beyond that. It was like a career interrupter, and they created programs that allowed women to maintain their jobs. Basically, it's maternity leave. Got reliable, more extensive maternity leave got added, and it removed that 18% decline. Findings suggest urgent need to improve healthcare and affordability, reducing or eliminating out-of-pocket costs, co-payments, co-insurance, deductible payments for recommended healthcare. One of the solutions she thinks could be useful, but it underscores the importance of stable insurance coverage for pregnant and postpartum women. A lot of women have to change coverage.
You change a job, you have to change coverage. You leave a job, you need to get COBRA and then find your own coverage. There are, the volatility of it is difficult to maintain. And when you change insurance, you have to sometimes change providers because not all providers take all insurances and there are different systems. And so you can't even have consistency in people who treat you.
Yeah. It does point out that the Affordable Care Act, that's that Obamacare dealio, has made some definite advances, has made things better. One of the things it did eliminate a lot of health plans that weren't actually health plans. Just called them health plans, even though they didn't cover anything. Usually you couldn't get anything covered, any kind of coverage for being pregnant.
Right.
And under a lot of these plans, which meant there were huge regions of the United States where you couldn't even get a healthcare plan to cover pregnancy. It all had to come out of pocket private, which is a ridiculous thing.
Which is a huge financial burden. Yeah.
Yeah. In short, there's little support from the healthcare system and the financial system in America for having children. And while there's growing political support for limiting women's access to birth control, following this trajectory will lead the nation down a path of worse and worse outcomes for newborn health.
Fire. You had a story about fire.
So Neanderthals used fire. We know that. Used it to warm the cave, cook with. And now we've discovering that they also used it to clear landscapes. Study by archaeologists from Leiden University in collaboration with researchers elsewhere found Neanderthals used fire to keep their landscapes open and did so for thousands of years. This is the Neumark Nord area. It's a quarry in Germany. They found abundant traces of Neanderthal activity, hundreds and hundreds of slaughtered animals surrounded by the stone tools the Neanderthals used, and a huge amount of charcoal remains. Traces were found in what 125,000 years ago was a forest area where they had prey like horses, deer, cattle, elephants, lions, hyenas. This is a quarry in Germany. I didn't know they had lions, hyenas there. Mixed deciduous forest stretched from the Netherlands to Poland. In several places in the area were lakes, and on the edges of some of these lakes, traces of Neanderthals have been found. Will Roebuck, an archaeology professor at Leiden University, explains that at the point when these Neanderthals turn up and start showing up in the record, the closed forest made way to open spaces, in part due to fires. So the question then was, okay, were there fires? And then the Neanderthals were like, hey, this is handy, this big open space, let's move there. Or did the Neanderthals move there and start fires and create open spaces? And they found sufficient evidence to conclude that the Neanderthals kept the area open for about 2,000 years, because they were shown that there's lake areas where the same animals roam, but there are no traces of Neanderthal, and there's no traces of fires.
Huh.
The fire seems to follow the Neanderthals everywhere they go on this landscape.
So they were using fire to clear the landscape, to manage the landscape, to help them hunt. All these
probably help hunt, to be able to look longer distances to see if there was like dangerous animals around. And
it was a tool. They were doing environmental management.
Yeah. Or they were just really bad at putting out fires. They were bad at campfires. We don't actually, I mean, that's one, right?
Yeah.
One idea is
One
they did this
interpretation is that they were
manage.
doing all this. Yeah.
Could have just been they were bad at putting out campfires. Like they didn't know how to do it. Hadn't been figured out.
Hopefully they were thinking about what they were doing. I like to think of the idea of our Neanderthal relatives as thoughtful. Yeah.
2,000 years of campfires. I think you figure out how to put a campfire out. If you
Maybe. That's neat though. What an interesting connection. The fire follows the Neanderthals. This is This Week in Science. We give you the gift of TWIS every week. Right now, it's the gift of TWISmas, and we hope that you all have a wonderful TWISmas with science. And please share this with a friend. I got some stories. How about some stories about the brain? Let me surprise you with something, huh? I never talk about the brain.
brains.
The brain, yes. Brain plasticity is crucial for our ability to learn, for the brain's ability to adapt, for the brain's ability to protect itself. This ability of the brain to form new connections, to be plastic. We think of it as kind of this moving thing where it's got these little projections, the dendrites, the axons that go out and connect with other neurons and that can make new connections, and that maybe it's constantly always moving around. But there is actually a part of the functioning of the brain in which it likes to not necessarily be plastic. When something's working really well, when connections are where they want to be, the brain likes to stabilize those things. And so in stabilizing those connections, they have an extracellular matrix, which is like scaffolding within the brain. And the scaffolding of the brain is made up of these metalloproteins, which is interesting, Justin, because on previous shows you've talked about these organic metalloprotein complexes that chemists are starting to use to do a lot of scaffolding and hold onto things in the environment. And so it's really fascinating, interesting that in the brain, we also have these metalloproteins that scaffold the structure, the architecture of the brain. So we have the stability that is provided by that extracellular matrix. But then when plasticity needs to happen, something needs to degrade those structural proteins so that growth and change can happen. And so there's a family of proteinases, these enzymes called matrix metalloproteinases, because they digest the metalloproteins or they enzymatically cleave them so that they break up and allow plasticity to occur. And so these researchers publishing in the Journal of Neuroscience this week looked at how a couple of these metalloproteinases are involved in mediating plasticity in the adult primary visual cortex. And so that in mice, so much in mice. This is like they give a gift to mice. No. In these mice, it's healthy adult mice, they were inhibiting the metalloproteinases to see what happened when they did these ocular dominance tests. So like one eye was covered up and not allowed to have any vision for a period of time, and they inhibited the metalloproteinase to see what would happen. They did the same with a different metalloproteinase after a cortical stroke that they initiated in the mouse brain to see what happened. And so they determined that when the brain was injured and needed to recover, the extracellular matrix provides this scaffolding for the synaptic circuits so that it's what they're thinking is that this an enzymatic proteolysis, what they call it, the process of the enzymes breaking up the proteins, regulates homeostasis between stability and reorganization or plasticity. And so they actually found that there was differential responses when the brain was in a healthy state and was kind of damaged, when these metalloproteinases were allowing plasticity to occur, or when the brain was injured and the plasticity occurred. And so in the brain, these enzymes work kind of balancing the need for stability or change. So in the future, we may end up in a situation where we are, able to use these metalloproteinases to help increase plasticity in a brain that has suffered a stroke, or when there's been damage and a brain is fighting and trying to maintain its rigidness, its structural integrity, but needs to be plastic so that behavioral function can be restored. Potentially, we can use these metalloproteinases as targets in the future to be able to therapeutically help people with brain injuries.
Yeah, inducing plasticity sounds like beneficial. Just in a midlife crisis, you're like, I don't like the way my brain is wired.
I need more plasticity in my life.
I want to rearrange my brain in a less painful way than has been done traditionally. Because that could actually even be
Just add some enzymes. So just no big deal. Just add the enzymes. And my last story for the night, it's all about life, because that is this planet's great gift to all of us. This TWISmas, we're going to talk about how life could have come to be. And we've talked so many times about so many different hypotheses about the origins of life on the planet. What are some of these stories that we've talked about over the years,
a couple
Justin?
of them. One is the panspermia. Life came via comet water.
Right, could have.
Another is the thermal vents, the clay down in the soil becoming the first structure that was like cell walls for chemical reactions to take place. Porous rocks, maybe. Or maybe that's the same as the clay one. Maybe it's only two. Pond water?
It didn't necessarily, it didn't have to be hydrothermal vents. It could have been volcanic ponds. It could have been just where hot water's happening. Yeah, but there are all these ideas, and there have been experiments through the years showing the chemical processes that, if you start with these ingredients, these little building blocks, you get these other pieces that could have gone on to become the building blocks of life, right? You have these things that could happen, this could happen. Okay, a new paper out in Frontiers of Microbiology has taken a look at all of the evidence to date related to the thermodynamics of the chemistry of hydrothermal vents. And the big take-home message, after analyzing over 400 chemical reactions that could have taken place in a very ancient ancestor of ours, they have said hydrothermal vents have all of the pieces in place to allow for the spontaneous construction of life that start based on the heat, based on the environment, based on the chemical starting blocks, that all of the factors are in place around hydrothermal vents to potentially the thermodynamics of the chemical reactions work so that they would step one chemical reaction on another to create all the possible parts needed to create something living. Now, there's a researcher, David Deemer, who's at, I think it's UC Santa Cruz, who proposed hot springs, this volcanic hot spring hypothesis for the origin of life years ago. And according to the scientist, he says the paper is impressive. Particularly significant is that their argument is based firmly on thermodynamic principles that revealed how molecular hydrogen in solution could act as a reducing agent to drive multiple reactions related to metabolism. And what's not yet addressed is how the reactions were encapsulated in some form of compartment. So that's the big question. You mentioned a clay or a mud, and that's another hypothesis that's been out there that maybe they're clay if there are sponge-like compartments near these, or sponges. No, there wouldn't have been
Well,
sponges.
you got to go back before the sponge. That's the
You got to go
problem.
back before that. But if the
There's
clay
nothing there
had
but mud.
compartments, yeah.
Bubbles. Something that
Bubbles.
made bubbles in mud.
Bubbles in
And you
mud,
got your
yeah.
compartments, your cell walls. You can have your little chemical reactions. Yeah. I got and something you said was, it's got the right conditions for metabolism. Oh, that sounds great. Wait. Back up. We got to start with just DNA. We got to start with something that's replicating. We got to start with, where do you even get that machine? How does this? What starts before the? I don't understand still. What has to come first? But I guess it doesn't have to necessarily be an intentional process.
Exactly.
Meaning, life is
It's
not
very
going to
likely
be
not intentional.
right.
Just
Right, and you try to start
thermodynamics
that way
and
because
chemistry.
when you back engineer and want to re-engineer, like, you have an intentional goal. You want to get from here to here to here to here. So you got to put this thing, and then we got to have this component, but this works with this. So how if these fit together so perfectly, how could they have just happened to be? Because they weren't. Nothing was designed. Things worked together because eventually things did. And that's kind
And
of
you
just
can
it.
imagine there are some chemical components in chemical systems we call some molecule
Chemistry
scavengers.
all the way down.
Yeah, we've got scavengers. And could you imagine the chemical processes that one chemical process is scavenging the energy from another chemical process? It's scavenging one thing from another. And eventually that scavenging turns into something that needs to be replicated, and the molecules start to align in a particular way. And processes can happen in a repeated way. And yeah, this idea, as Bradley White is saying in the chat, abiogenesis. Yeah. Where life came just from the stuff that was. Luck of the draw, all the right things in the right place, but I think at the end of the day, it makes for a merry TWISmas. Life, it finds a way.
Yeah, those are some words. Also, the chemical reactions that we're talking about aren't going to be completely unique to one planet in our universe, in our galaxy.
Nope.
There's going to be plenty of planets that have the similar chemistry, that have the similar thermo events, maybe even have similar size and amounts of water, and all those things that we think are crucial in this instance. And there may be other ways. It might be the thermal vents here, could be the muck ponds of another planet. It could be something that happens in a dry space. It's a very humid environment.
They say here, though, the key factor to these processes happening here is hydrogen. If you take hydrogen out, nothing works.
Oh, gosh. And what's the most abundant element in the universe?
Hydrogen.
There you go.
Hydrogen. Everywhere.
Life's going to be everywhere out there.
It is.
Does it have a sense of humor?
Have we done it?
Think so.
We made it to the end of another episode.
Yeah.
Our very, very special TWISmas episode. You know, every episode is special, but this week we're celebrating all the science, saying thank you all for being here. There was one TWISmas, 2014, I believe, episode 494, when Justin's disclaimer read, "'Twas the night before TWISmas, when all through the house no science was stirring, not even a mouse. The stories were laid by the webcam with care, in hopes that the minions soon would be there. Blair was already hiding her bed, while visions of peacock spiders danced in her head, and Kiki in her lab coat and I on the moon, preparing our brains to bring the show soon. When all of a sudden, There arose such a clatter. So to the chat room, I sprang to see what was the matter. The minions were there, and the minions were ready for the show to begin and the news to come steady. I opened a window, and I saw with surprise that the Google Hangout was going, about to be live. I looked for my invite. I found it in text, just in time for This Week in Science. Coming up week after next. It's going to be week after next is our next episode, December 29th, for our top 11 science stories of the year.
Yeah, that's one of my favorite shows. The recap all the great science. That was a great disclaimer. I should have done that one today instead of that god-awful thing that I was trying.
Oh, it was fantastic. I think we should try and do it again in the after show.
Oh, no.
Let's do it again. Do it again. Do it again.
I don't think I can do it. All right. Yeah. So next week is the top 11.
No. Next week is our week off. TWIS is taking a week.
Taking a week off.
We're taking a week off.
Why do we do that? That's insane. Nobody takes a week off.
Well, it's one night to some. It's a week. It's a week in between. But the 29th, we're coming back with our top 11 science stories show. If you would like to let us know what stories you think should be in the top 11, please do email, or you can hashtag us on Twitter with TWIS top 11, and we will be able to see your recommendations. Yes. No peacock spiders this year. I don't think we had any peacock spider stories in 2021. Which stories will make our final countdown? Oh, the tension is rising. You have 2 weeks before we tell you.
Dun, dun, dun. All right, I think I already know what mine are.
But now we have come to the end of our episode. So I just want to say thank you so much for listening. And I hope you did enjoy this show. Shout outs. Fada, thank you for your help on the social medias and for show notes and all the other things you do. Gord, thank you for manning the chat rooms. And Identity 4, thank you for recording the show. Rachel, thank you for editing and for other assistance that you give. And I definitely would like to thank our Patreon sponsors. Thank you too! Richard Badge, Kent Northcote, Pierre Velazar, Ralph E. Figueroa, John Ratnaswamy, Carl Kornfeld, Karen Tazi, Woody MS, Andre Bissett, Chris Wozniak, Dave Bunn, Vegard Chefdad, Hal Snyder, Jonathan Stiles, aka Don Stylo, John Lee, Ali Coffin, Maddie Perrin, Gaurav Sharma, Don Mundis, Stephen Alberon, Daryl Myshak, Stu Pollock, Andrew Swanson, Curtis 104, Sky Luke, Paul Ronovich, Kevin Reardon, Noodles Jack, Brian Carrington, Matt Bass, Sean and Neil Lamb, John McKee, Greg Riley, Mark Hessenflow, Gene Tellier, Steve Leisman, aka Zima, Ken Hayes, Howard Tan, Christopher Rappin, Dana Pearson, Richard, Brendan Minish, Johnny Gridley, Kevin Railsback, Rami Day, Flying Out, Christopher Dreyer, Artyom, Greg Briggs, John Atwood, Hayes, Arizona, support Aaron Lieberman for governor, Rudy Garcia, Dave Wilkinson, Rodney Lewis, Paul Mallory Sutter, Philip Shane, Kurt Larson, Craig Landon, Mountain Sloth, Jim Drapeau, Sarah Chavez, Sue Doster, Jason Olds, Dave Neighbor, Eric Knapp, E.O., Kevin Parachan, Aaron Luthen, Steve DeBell, Bob Calder, Marjorie, Paul Disney, David Simmerly, Patrick Pecoraro, Tony Steele, Ulysses Adkins, and Jason Roberts. Thank you for all of your support of TWIS on Patreon. And if you would like to support us on Patreon, head over to twis.org and click on the Patreon link. On next week's show, there's no show. On December 29th show,
we will be back on Wednesday, 8 p.m. Pacific time, or Thursday, 5 a.m. Central European time, broadcasting live from our YouTube and Facebook channels and from twis.org/live.
Want to listen to us as a podcast? Because that's what we do. We podcast. Just search for This Week in Science wherever podcasts are found. If you enjoyed the show, get your friends to subscribe too.
For more information on anything you've heard here today, show notes and links to stories will be available on our website, www.twis.org, and you can also sign up for a newsletter if that's your thing.
Oh, yeah. You can contact us directly. Email me, Kirsten at thisweekinscience.com, Justin at TWISminion@gmail.com, or Blair Baz at twist.org. One of these days, I will give everybody the same email address domain. Just put TWIS in the subject line so your email doesn't get spam filtered into a hydrothermal vent and respawn life or a guinea worm.
We'll be back next. Oh, wait, no, that's not the one. You can also hit us up on the Twitter, where we are at TWISscience, at Dr. Kiki, at Jackson Fly, and at Blair's Menagerie. We love your feedback. If there's a topic you'd like us to cover or address, a suggestion for an interview, a haiku that comes to you tonight, please let us know.
And we will be back here December 29th.
So tough.
For our last show of the year's top 11 science stories of the year. We hope that you'll join us again for more great science news.
And if you've learned anything from the show, remember,
it's all in your head.
This Week in Science. This Week in Science. This Week in Science. This Week in Science is the end of the world, so I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice, show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand, and all it'll cost you is a couple of grand. 'Cause this week's science is coming your way, so everybody listen to what I say. I use the scientific method for all that it's worth, and I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in 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 Science. This Week